Jai Hind to all. This is Santosh Kumar Mishra, Assistant Professor in Information Technology Department at Ajay Kumar Garg Engineering College. In today's lecture, we will study what the recursion is, how the recursive call of the functions are performed, and what are the advantages and disadvantages of recursion. And after that, we will start array, and in that we will study one dimensional array and two dimensional array, and we will look how the operations on over the arrays of one dimensional or two dimensionals are performed, and for that we will see some matrix operations over the two dimensional array. So, let us start what the recursion is. Recursion, as the definition says, a process in which the function call itself repeatedly until some conditions are satisfied. Means in recursive calling, the function is called by itself within its body with some smaller value. Whenever we want to break a bigger problem into a smaller one, then the concept of recursions takes place, and there the divide and conquer approach are working, and here the function call itself within its body with some smaller values, and the calling of the functions terminate at a condition that is also called the base condition. If we do not specify the base condition in a proper manner, then the recursive calling of the function will go to the infinite loop, and that will hang up, that will fill up the RAM of your system. That is why we have to take care of this base condition. The example of recursive calling are given here. We have defined a function a where I have passed a number n, and if n equals to 1, it returns 1, else it returns n plus a n minus 1. You can see that this function a is calling to itself within its body. This is the body of this function, and this function is calling to itself. This one is the calling of this function a into its body, and calling of the function to itself within its body is called the recursion, and this is the condition that we call the base condition, where the recursive calling of this function a will terminate. Let us look it by explaining. I am going to explain this with more examples. Let us move ahead. This one is the recursive function a n minus 1. Here the function a is calling itself, and this one is the base condition of this recursive calling. Now, if we want to perform the factorial of a number using recursive calling, there are chances that this question of calculating the factorial of a number using recursive calling comes into the university exam also. That is why you all have to take care of this program. If we want to calculate the factorial of a number, as we all know mathematically that factorial of n equals to 1 into 2 into 3 up to n minus 1, we multiply all the numbers and we get the factorial. Means if the factorial of 5 has to be calculated, then the factorial of 5 is 1 into 2 into 3 into 4 into 5, means you have to multiply the numbers up to that number. In another way, we can say that the factorial of n is n into factorial n minus 1. So, the logic of calculating the factorial is to calculate the factorial of a number. If the value of n is 0, then the factorial of that number is 1, as we all know that the factorial of 0 is 1. So, if the number is 0, n is 0, then the factorial should be calculated as 1, and this we keep it as a base condition. and if n is greater than 0, in that situation the factorial of n is n into factorial n minus 1. This logic may be implemented in the form of a recursive function calling like this: a factorial of fact n, we will declare a fact n function that will return some factorial in integer or some data type format, and if n is 0, the factorial this function must return 1, and if n is greater than 0, this function must return into n into fact n minus 1, and this same logic we will implement in this function, in this recursive calling of the function. In fact, it is, we have passed the number n that we want to calculate the factorial, and if the value of n equals to 0, then it must return 1, and if otherwise, if the value of n is greater than 0, it will automatically go to the else block and it will return n into fact n minus 1. This is the logic. This logic may be implemented in this program that I am writing here. If the we are declaring in last class I have explained what is the function and how the function are called, and you can remember that before defining the function we have to write the prototype declaration of the function that I have written over here. The prototype of fact function is given over here. Then we start the main function, and in main function we just entered a number n, and then for entering that number we use this scanf function. In that we enter the number into num variable and we call the function fact num, where the num has passed by value to this fact function, and this fact function are defined over here in the right hand side, where if n equals to 0, it returns 1, otherwise its return n into fact n minus 1. Here you can see that this fact function is calling to itself, this fact function is calling to itself with a smaller value within its body, and this is the recursive calling. And this function fact has been called over here by passing this number n, and by passing this number n num, and this function jump to this location by copying the value of num to this formal parameter n, and that after taking this input it calculates the factorial and returns the result back to the main function that will be assigned to this variable f, and this f will be printed. This way you can understand that how, if we take the input 4 as a num variable, if we pass the value of 4, this 4 will go to the num variable and factorial of 4 will be calculated like this. First the fact 4 will be called. You can see that the fact 4 will be called. Let me erase this writing work, and after that we will see it clearly. This whenever let's we have entered number 4, we have entered number 4 as input, means 4 is the value of this num, and we are calling this fact num, means fact 4, means fact 4 will be called, and this fact 4 will jump to the control over here. The value of n is 4 now. It checks whether 4 is equals to 0, because n is 0, n is 4, because we have passed the value of n as 4. This 4 will be copied to this n variable, means the value of n is 4. Now the function body will be executed. N means 4 is equals to 0 becomes false, means control will come to here and it returns n into, means 4 into fact 3, means it will return 4 into fact 3. Similarly fact 3 has been called, control will call its, the fact function will be called again by this fact 3. Now the value of n is 3, the control will again calculate 3 into fact 2, means 3 into fact 2 will be calculated. This fact 2 is again called, means fact function has been again called. Now it will return 2 into fact 1, and then the value of n is 1. Now the fact function will again be called with the value 1 as the n, and now 1 into fact 0 is calculated. Fact 0 is now calculated, means the fact 0 has been called. Now control will come to the function body, and now the value of n is 0. N is 0 means if now control will come to this body, n equals to 0 become true, and it will return the value 1, means finally fact 0 will return the value 1. Here the recursive calling will terminate. It will return 1. 1 into 1 will be calculated, and the result will be returned back to the fact 1 function. Here fact 1 means 1 has been returned, 1 into 2 will be calculated, and 1 into 2 will return back. Now fact 2 returns 2, means 3 into 2 is calculated, 6 is returned back. Fact 3 is called, 6 into 4 will be calculated, and 24 will be returned. This way fact 4 returns 24, and that 24 will be assigned to this f variable, and that will be printed over here. This way we can see that if he does not properly implement this base condition, the recursive call may go to the infinite calling, and that infinite calling will hang up your RAM, will hang up our system. That's why it will go to the infinite loop. That's why the base condition must be appropriately devised. This has been written over here also. Fact 4 called, fact 4 means 4 into fact 3 will be returned. Fact 3 will call 3 into fact 2, 3 into fact 2 will be returned. Fact 2 will call 2 into fact 1, fact 1 will call 1 into fact 0, and fact 0 will return 1, and finally this value will be pop up from the stack, and it will return back to the f as 24, and that 24 will be printed. One more things I want to explain over here, that whenever the recursive calling is there, there is a management of stack are there. Stack are managed to push and pop the intermediate results, and for maintaining the stack there, as the running time of your program will increase. So whenever there is a way to choose whether you will prefer recursive calling or iterative calling, we should follow the iterative calling, because the execution time of iterative calling is reduced as compared to the recursive calling. But in the advantage of recursive calling is that in recursive calling the number of code, the line of code may reduce very much, and that will enhance the programming capability of the programmer. But in sense of the running time of recursive calling are worse than the running time of iterative calling. So we can appropriately decide whether to use the iteration or recursion depending upon our situations. Here the factorial 4 are being calculated. This same concept has been shown by some diagram. Fact 4 has been called, means fact 4 will return 4 into fact 3, fact 3 will return 3 into fact 2, 3 into fact 2, fact 2 will return 2 into fact 1, and fact 1 will return 1 into fact 0, and fact 0 will return the value 1 back to the fact 1. Fact 1 will calculate 1 into 1, and it will return 1 as to the previous function, means 2 into 1 will be calculated, it will be returned back, then 3 into 2 will be calculated, it will be returned back, then 4 into 6 will be calculated, it will be returned back, and that will be assigned to the function f, that will be assigned to the to the variable f, and that variable may be printed. Here a recursive program for calculating the exponent of a number has been given, and I have to find the a to the power b. We want to implement the power function given in the math.s file, but we want to write our own function. To write that means we want to find the value of a to the power b by our function, and for that we may write the recursive function. A to the power b means calculating a multiplying the value a to b times, means a to the power means multiplying a to the b times. Calculating 2 to the power 3 means finding multiplying 2 to 3 times, 2 into 2 into 2 is 2 to the power 3, and the same concept we can say that to find the a to the power b, we can say that a into b ke power minus 1 may be calculated, a into b to the power minus 1 may be calculated, and for that I may devise a logic that if the value of exponent is 0, the value of power will be 1, whatever the base is. If the value of exponent is 0, the value of the power function must return 1, and if it is greater than 0, then it must return a into b to the power minus 1. And for that same logic I have written a my x function, this user defined function my x, we are passing a as a base and b as a exponent, and it will calculate, it will return 1 as the output if the value of exponent is 0, and it will return a into my x, a into a to a b minus 1 if b is greater than 0. Means this same function my x may be called if the value of b is greater than 0, a into my x a comma b minus 1 may be called again, and same logic has been implemented in this function. It my x function has two formal parameters a and b, and if the value of b equals to 0, means if the value of exponent equals to 0, it returns 1, else it returns a into my x a comma b minus 1, and this way we can find the exponent of a to power of a to the power b, we can find the value of a to the power b, and this same concept has been implemented in the form of a program over here, and here you can see that I have defined the my x function to the right hand side. My x, it has two parameters a and b, same concept has been implemented. If the value of b equals to 0, it returns 1, because the exponent, if the exponent value is 0, the whatever base is there, the result is 1, otherwise it returns a into my x a comma b minus 1. This way this function when called into the my x function is called to the main function, then control will come to here, and if the, let us say we have taken input 2 and 4, the value of a is 2 and the value of b is 4, then 2 to the power 4 16 will be calculated like this. To calculate it, my x 2 comma 4 is called, and it my x 2 comma 4 will call 2 into my x 2 comma n minus b minus 1 means 4 minus 1 means 3. Now my x 2 comma 3 will call 2 into my x 2 comma b minus 1 means 3 minus 1 2. Now my x 2 comma 2 will call 2 into my x 2 comma 1, and my x 2 comma 1 will call 2 into my x 2 comma 1 minus 1 means 0, and this 0 is the base condition, it will return the value 1, and 2 into 1 will be calculated and returned back to the my x 2 comma 1. Now 2 comma 2 is will calculated, it will return back. Now 4 comma 2 will be calculated, it will return back, and 8 comma 2 will be calculated and it will be returned back, and means my x 2 comma 4 will return this 16, and that will be assigned to the variable p, and this way this p are now printed in the form of, this has been, you can see in the previous program, this has been p, my x comma y is returning, it has been assigned to p, and this p has been printed into the next instruction. This way recursively we can devise a function that call its recursively to calculate the exponent of any number. We can find the power of a to the power like this by calling this function. Now we will move ahead and see how the Fibonacci series up to n terms may be calculated. As we all know that the Fibonacci series first term is 0, the next term is 1, and the next term is the summation of the previous two term. Means if first term is 0, fib 2 means next term is 0, then fib 3 means next term will be 0 plus 1, that will be 1, and similarly fib 6 means fib 5 plus fib 4 means previous two term sum will be the next term. This is the concept of Fibonacci series, and to devise that we check if the value of n equals to 1, it returns 0, if value of n equals to 2, it returns 1, and if otherwise in that, if the value of n greater than 2, it returns the summation of calling of the previous two terms of the function. Means for greater than 2 value of n, the fib n minus 1 plus fib n minus 2 will be calculated and summed up, and this way it will return the value. And this concept may be implemented in the form of the recursive calling of the function. Over here that I has been written the fib function where I have passed the value of n, and if the value of n equals to 1, it returns 0, as previously in the logic I has been explaining previously. I have explained that, and else if the value of if the value of n is 2, it returns 1. Similarly previous example has been given, and else otherwise it will find the sum of previous two terms and return that. And same concept has been implemented in the form of a program. Over here the num variable will hold the number of terms that we want to print from the Fibonacci series, and for that we create a loop, that we create a for loop, and in that for loop from 1 to num we have executed that for loop and called the fib of I. Means firstly fib 1 will be called, and as we have seen that fib 1 will return 0, fib 2 will return 1, and fib greater than 2 will return fib sum of the previous two function. And this way the Fibonacci series, here is the program, here is the definition of that function. If the value of n equals to 1, it returns 0, else if the value of n equals to 2, it returns 1, otherwise it returns the sum of the previous two terms, the sum of the fib n minus 1 plus fib n minus 2, and this way the Fibonacci series may be printed like this. 6 is the number of term, the first 6 term will be printed. This way we can see that the fib function means fib 4 is calling, let us say the value of n is num is 4, fib 4 has been called, and fib 4 will call fib 3 plus fib 2, means the sum of the previous two term will be called, and fib 3 will call the sum of fib 2 plus fib 1, and we all know that the value of fib 2 is 1, and the value of fib1 is 0, the 0 plus 1 will be returned over here as 1, and fib2 will return 1, and this way fib2 will be returned. This way the Fibonacci series is being printed. Now I hope you all understand what the recursive calling is, and the main point is that whenever the recursive calling is there, we have to take care of the base condition. If the base condition is not being properly defined, then the recursive calling may go to the infinite loop, and this will create the problem. And the second, the recursion means calling the function to itself within its body, and this type of concept is useful whenever we want the divide and conquer approach has to be applied. And whenever I will tell the, let us say one example, binary search programming, and there you can see that how the recursion, how the concept of divide and conquer works. Now the next topic that we have to study today is array. What the array is? Array is a homogeneous, let us start it. Array is a homogeneous collection of data. Whenever we want to store a number of data, then in that situation, and those all data are of the same type, in that situation we will like to use the concept of array. Array is the collection of homogeneous data type. Homogeneous means similar type of data, is the collection of similar type of data is array. One key concept is there, all the elements of the array are stored in the contiguous memory location, and we already studied that array is a derived data type that has been defined from the previously devised primitive data type, means it is a derived data type. It is collection of similar type of data. It's all data are stored in the contiguous memory location, and it is a derived data type. To declare a normal variable, we use like this, we use the declaration like this, but the problem is that if one variable has been defined, it can hold only single value at a time. If we want to store many values in a single variable, in that situation we will use the concept of array. Here we have defined a array A of 10 size, and it is of integer type, means it will store 10 integer value, and those 10 integer value may be accessed by the index value like this. The first value, array index always start with 0, so the first value will be accessed from A of 0, means A of 0. By writing like A of 0, we can access the first element. By writing A of 1, we may access the second element, and so on. The first element will be A of 0, and the last element of the 10 size array will be A of 9. This way, if we are now accessing, we have started to accessing the elements. If we want to input the value into this memory location, we may put it into the scanf, into the for loop, and there we will write the scanf function, and if for printing that we will write into the for loop, and we will use the printer function. We will later on see it. There are two types of array. One is one dimensional array, where a data is stored into a single row or into a single column, and there are multi-dimensional array, where majorly used array are two-dimensional array, where the data are stored in the form of some rows and column. There are three-dimensional array also, 3, 4, 5, 6, any dimension array may be there, and we will see it. First start one dimensional array. One dimensional array, to declaring it, we have to use one subscript over here. This is also called subscript. We declare it by writing the data type, then array name, and in subscript we will mention the size of the array. And for example, we have already seen that integer array named A of 10 size has been declared over here, and whenever we will declare the memory, 10 memory will be created, and the first memory location will be accessed by writing A of 0, next will be A of 1 and so on, and all these memory location will be into the contiguous form. Now to initialize the elements into the one dimensional array, directly like this: int A of 10 equals to, in curly braces we have put the 10 comma separated value, and then after we will put a semicolon. It will assign 1 to the A of 0, 2 to the A of 1, 3 to the A of 2 and so on, and like this it will store 1 to the A of 0, 2 to the A of 1, 3 to the A of 2 and so on. It will store the elements into the contiguous memory location. Now this let us understand a program. If we want to enter the elements and elements in an array and display them, we have first declare a array. Let's say we have declared a array of 20 size of integer type, and we just enter the value of n. The n is the number of elements that we want to enter to that array, and to enter the value, since we have declared n elements and we have to take the n elements as the input, and to take n inputs we have to write n times scanf function, and the better approach is that we just write this scanf function to the for loop, and this loop will start from 0 to less than n, because the array index always start with 0. That's why this loop has been started from the 0, and we scan like this. We write scanf %d, means because the array is a integer type, comma, and A of I, the value of I will be 0. Whenever the first time this loop will execute, the value of I will be 0, and the element that will be input will be goes to the address of A of 0. It will stored to the location A of 0. Now the I will be incremented to 1. The next element will be input to the A of 1. I will be incremented to 2. The next element will be input to the A of 2 and so on. This way the array will be filled up to the n times, and elements will be input to that array. By declaring, we have just created a blank array, and whenever we take the input like this, the input will be goes to that memory location, to that variables, and to print that n elements, we put the same concept. We create the loop from 0 to less than n and put it into the printer %d A of I. This way A of I will be 0. First time A of 0 will be printed whenever the loop will go to the first time. I will be 1, then A of 1 will be printed, and this way the whole array will be printed. This way, to take the input we will use one for loop, and to take the print the output we will take another for loop, and this way you can take the array into the one dimensional array. We can take the elements into the one dimensional array and print them. Here I have written a program to take the elements directly. We have assigned the values directly, that I have already explained you. The 1 will be stored to the A of 0, 2 will be stored to the A of 1 and so on, and by putting into the for loop, by putting the printf into the for loop, we have just printed those elements. Now this way it will be printed. Now let's have a program that will find the sum of that will we have a program. We can directly assign the value to the elements also. Means if we have assigned 5 size array, we have declared 5 size array, A of 0 has been assigned 1, A of 1 has been assigned 2 and so on. This way you can directly assign the value, and that may be printed. Okay, it is very easy concept. The means direct elements has been assigned, means 5 has been assigned to the A of 4, 3 has been assigned to A of 2, and 5, these 5 elements can be directly assigned without any for loop, and this has been printed. 5 elements are there, means we will create a for loop from 0 to less than 5, and A of I will be printed to that for loop. This way you can also perform the input and output to the array. Let's now find the sum of n elements of a array, and we all know that we have 4 elements, and A of 0 has 5, A of 1 and say 7, and so on as shown in the slide, and we want to find the sum of these elements. To perform that, we first assign a variable. We will create a variable that will be assigned 0. I have created a sum variable that has been assigned 0, and then this sum will be updated. We will access this first element, value, and we will add to this sum. Now the sum will be updated as 0 plus 5. This 5 has been accessed and added to the sum. Now the sum has been updated. Now we will move to the next element, and 7 will be again added to the sum element. 7 will be again added to the sum variable, and now the sum will be updated to the 7 plus 5, 12. Now we will move to the next element. This element will be accessed, and this element will be summed up to the 12, means previous sum will be keep on updated whenever the next element are there. This way you can find the sum of all the elements of the array. And this concept has been, the logic of this is here. We will create sum equals to 0, and to access each element of the array we will create a for loop from 0 to less than n, and by this writing A of I, we are accessing each element, and each element has been added to the sum variable, and this has been assigned to the sum, means sum is going to be updated every time whenever the loop is incremented. The next element is accessed and added to the sum variable, means sum is going to be updated every time by adding to the next element. This way you can find the sum of the array. This has been written in the form of the program. I have array A, and sum equals to 0 sum has been assigned to 0, and we have taken the number of element n, and to take the input to this n elements we create the for loop, and this for loop I have taken the input by putting it into the scanf function, scanf %d and A of I. Each element will be taken input, and this element will be added to the sum and assigned to the sum back to sum variable. This way each element will be input and added to the sum variable. The sum, whenever the loop will be completed, sum has the summation of all the elements of the array that may be printed. Here is the elements of the array, and its sum are printed outside the loop by writing this printf function. Okay, we can find the sum of the elements of the array like this. Okay, now we have number of elements 4, and the elements are 5, 7, 2, 6, then the sum will be 20. Okay, now if we want to find the sum of all the even elements and odd elements of an array, the same concept may be implemented. We may access each elements of the array, and we will check the condition whether that element is even or odd. If it is even, we will add to the, let us say, some even variable, and if it is odd, we will add to the some odd variable. Means the same concept may be here. N is the number of elements. Let's we take the n as the number of elements, and to access those elements, firstly we scan the elements. Firstly, by putting it into the for loop from 0 to less than n, we scanned each elements, and we checked if the A of I modulus 2 equals to 0, means if the A of I element is even, it will be added to the some even, otherwise it will be added to the some odd. If it is divided by, it is divisible by 2, it is even, otherwise odd. If it is divisible by 2, the element is added to the even sum, sum even, otherwise it is added to the odd sum. Okay, this way you can find the sum of all the even elements or odd elements of the elements, and after that we may print it by this printf function. By this printf function, all the sum of all the odd elements has been printed to the sum odd, and all the odd elements are printed by sum even. This way you can find the sum of all the even and odd numbers of a array. Okay. Now, if we want to find the maximum of an maximum element of an array, firstly we take the n as the number of elements into the array, and we input the array by writing into the for loop. We take the scanf here, and a of I means the array has been taken input, all the elements are being input by this for loop. And let's the first element, let this one is the array, and it has 4 elements, let's say 3, 7, 9 and 2. And we, what the logic is, we firstly consider the first element of the array is the maximum element, and for that we have assigned a of 0, because the first element of the array is a of 0. A of 0 has been assigned to the max variable. Now we will access each element. Now we will access each element and compare it with the max, and if the next element is greater than max, the max will be updated to that element itself. Like this, we started the loop from 1 to less than n, because first element has been assigned, a of 0 has been assigned to the max. So we will start from the 1 to less than n, means a of I means a of 1. If a of 1 is greater than max, means if a of 1 is greater than a of 0, in that case max is updated to a of 1. The max is updated to a of 1, because the value of I is, means if the next element is, greater than, if next element is greater than max element, that it will be updated, means max will be updated to a of 1, and it will keep on checking, and the max will be keep on updating, and finally maximum element will be assigned to the max variable, and after the loop we can print that. This way we can handle the one dimensional array. In the next lecture we will cover two dimensional array. I will cover the two dimensional array, and we will move ahead to the next concept. Okay, we will meet to the next lecture. Thank you, thanks a lot.